Page 188 in your textbooks, you did numbers 1 through 14, the teal problems. We are reviewing today. We're reviewing tomorrow for your test coming up on Friday. That's lesson 105. If you want to jot this down, the test covers sections 4.1 to 4.5. 4.1 to 4.5. Good save. And basically everything we've covered since we came back from Christmas break about 3 weeks ago. Anyway, so one of the things we talked about was slope. Remember, we said there's 4 different kinds of slope. A line that goes like this, class, has positive slope. Like this would be negative slope. Straight up and down, undefined slope, and perfectly horizontal, 0 slope. Number 1, the line is in slope-intercept form. So we can see what the slope of number 1 is. What is the slope, Brandon? Negative 2, so therefore it has obviously negative slope because it's negative 2. Number 2, I didn't ask you to do it, but what would the slope be there, anyone? 0, because you could say y equals 0x plus 2. Anyway, that in a constant function f of x equals 2 would be a horizontal line with a constant f of x or y value of 2. Anyway, that's great. Number 3, you're supposed to graph using the given point and the slope. I'm going to be lazy and not bother pulling down the graph grid there, which makes me wonder why do I even have it there. But anyway, so you draw your graph grid. Of course, you take the time to make sure it looks good so you don't lose points on a quiz or test, like the one coming up in lesson 105. And you start by plotting the point they gave you. They gave you the point -1, 0, -1, 0.
We only did the teals.
Oh, you only did the teals. Sorry, my brain's going through all these odd numbered problems here. Teal. Yeah, good call. You didn't do that. Well, you would have done that, and you would have risen 7 and run backward when I drawn that. All right.
Yeah.
Let's try number 5. Thank you, sir. My brain's all set to go down the odds, and it says teal right there. Find the midpoint. What's the formula we use to find midpoint, Abby?
M equals x1 plus x2 over y1 plus y2.
X1 plus X2.
Over y1 plus y2.
Audrey?
Over 2.
Over 2, and then... Yeah, we're going to average the x's, we're going to average the y's and divide by 2. Now, I'm guessing Abby forgot how to do it and asked her brother. And her brother gave misinformation because she is glaring at him and he is laughing. And what would be really funny, Michael, is if you had the right answer here and you purposely misled your sister. That would be partly sad and partly funny all at once. But we're going to go back to Abby, who's going to be done glaring at her brother now. Though, if she cooks something tonight, I would pass.
I'm going on visitations. So
okay, all right. So Abby, when we add the x values on number 5, we get 4, and then divide it by 2. 2. And then we add the y's.
Negative 28.
Cut that in half.
Negative 13.
That's the midpoint. It's the point that's midway between those other values. So midway between the x's is a 2. Midway between the y's is a negative 14. That's the midpoint. So Michael, number 6. What would the midpoint be?
3, -10.
3, -10 is correct. All right, questions on 5 and 6. How many had 5 and 6 correct? Everybody but Abby. All right.
Sorry, I honestly thought I explained the right formula. I guess I didn't. I don't know what I was doing, but it wasn't the right one.
Well, I really, I can't blame him because you asked him. Like, of all the people you could have asked, him.
He was like the only one who studied.
Brandon is much more trustworthy than me.
Brandon was in study hall.
I was the only one that you could ask.
You know your brother and you still ask him. All right. Anyway. All right. Number 7 says convert to slope-intercept form and graph. So this is where the graphs come in. This is the teal problem. To get an equation into slope-intercept form, the first thing I need to do in Genesis is get the, and to do that, 2 things.
12 to 3x over negative 3x equals positive.
All right, you get 12y equals positive 3x minus 24, and then
Find everything.
and then I get
Y equals 1/4x minus 2.
all right. So when you graphed it on your graph paper, here's where graph paper comes in. We start by plotting the
Negative 2.
as our
Y.
y-intercept. So not right here. No. Right here. -2. And then from there we need to
Minus 1. Run 4.
forward 4, positive 4. So 1, 2, 3, 4. Go right there. And when we connect the dots, we get a line that looks something like that. How many in a line? It looks something like that for number 7. Questions on 7? How many use the x-intercept? I could tell by Audrey's face. She was an x-intercept person. Don't do that on the test on Friday. Other questions?
I had that, but my line is like this.
Did you rise 4 and run 1?
I don't know, maybe.
I feel like you might have gotten your rise and run backward. Because if it's like this, you rose 4, ran 1 instead of rise 1, run 4.
I must have done that then.
Okay. Number 8. Let's go to Maddie. They give us an x plus 3y is equal to 12. What do we need to do here? Okay, so you get 3y equals negative x positive 12.
And then divide it with 3. And then y equals -1 plus 4.
All right, I will graph it here, and for starters, we plot the
Positive 4.
as our.
Y-intercept.
Then from there, we need to
Rise 1 and run -3.
and so should have gotten a line that looks something like that. For number 8, how many in a line like that for number 8? All right, so we're all good on 8. It was just had a little trouble on 7 questions on slope-intercept form. Evidently, we didn't do 9 or 10, so let's drop down to number 11. Write the equation of the line that passes through a given point and is parallel to the given line. So they give us the point 3, -11, and they say that our line has to go through that point, and it's going to be parallel to y equals -2/7 x minus 4. Kendall, how do I find the equation of this line? What 2 things do I need to know the equation of a line? And the good. But when it says parallel, parallel means so if the line they give me is y equals -2/7 x minus 4, I already know my slope. I know my slope is -2/7. What I don't know is the y-intercept, right? How do I find the y-intercept?
Could you start with the slope-intercept?
Let's start by writing out the y equals mx plus b, and then we're going to plug in
The -11 for y, and then the -2/7, and then the 3.
and I'm going to put the 3 over 1 plus the b. Here nothing cancels, unfortunately. I get,
-6/7.
and I'm going to move, well, I guess I could move it over, or I could just clear the fraction out first. What do you want to do?
Clear the fraction.
Let's do it.
You can multiply by 7.
If we multiply the entire thing by 7, I get,
-7/7 equals -6 plus 7. And then you divide.
not yet.
And then you move it over.
There we go.
So you get -7. And then you divide by 7.
And so obviously the b value is
7, no. -71/7.
-71 You could say -10 and 1/7, I suppose. So what's my equation?
Y equals -2/7 x minus 7.
Notice it starts the same as the other equation, right? Because it's parallel, just has a different y-intercept. How many have this equation? For number 11. Now it did say to write the answer in standard form, so we could have multiplied everything by a 7 to get 7y equals -2x minus 71, and then just move the 2x forward to get 2x plus 7y equals -71. That's what the book was looking for. I'm usually content with the slope-intercept form. On the test, since I write the test, I'm not going to ask for standard form. I'll let you leave it in the slope-intercept form. Did anyone go to standard form by any chance? Okay, a couple of you did. Is this what you had? Yes, but no. All right, question. You didn't ask him for help, did you?
No.
Okay, good. All right, questions on 11. Let's take a look at number 12. Very similar problem. I already know the slope on number 12 class is going to be -3/4, because that's the slope of their line, and my line's parallel to it. But mine goes through the point 8, 9. So I'm going to start by saying y equals mx plus b. That's an 8. It just didn't turn out very good. I'm going to be able to cancel here, class, to get 1 and 2, multiply to get -6. Move the -6 over as a 6 to get 15 for my b. So if there's my m, there's my b. What's the equation, Abby?
Y equals negative 3/4 x plus 15.
And again, if you did this in the standard form, you would have had a 3x, positive 4y equals 60. So either this, which is what I think most of us got, or possibly that. How many had one of those equations for number 12? Questions? All right. Number 13, very similar problem, except this time instead of saying parallel, it says perpendicular. Class, when it says perpendicular, what 3 words do I need to think?
Negative reciprocal slope.
Negative reciprocal slope. So on number 13, the slope of their line, Brandon, was?
Negative 1/5.
Negative 1/5. But the slope of my line, Audrey, is going to be?
5.
Positive 5. And it goes through the point, negative 1, negative 5. All right, pretty straightforward. We say y equals mx plus b. What's going to happen to the negative 5 and this negative 5? To get b equals
0.
So my equation is y equals 5x. You could say plus 0 if you wanted to. I usually don't. This is y equals 5x. How many had that for number 13? Or you might have had 5x minus y equals 0 if you did it in the standard form. Okay, questions? Number 14. Their line has what slope, class?
Negative 4/7.
Negative 4/7. My line on number 14 has to have a slope of
7/4.
positive 7/4. And it goes through the point 4, 9. Again, y equals mx plus b. Canceled the 4. Subtract the 7 to get b equals 2. So y equals 7/4 x plus 2. Or you might have had 7x minus 4y equals negative 8, I believe. Yeah, if you went the standard form. How many were those two equations for number 14? Questions on parallel perpendicular. All right, and that takes care of the 1 through 14 teal. I noticed they didn't ask for distance. What's the distance formula, Audrey?
The square root of x2 minus x1 squared plus y2 minus y1 squared.
Good. They also didn't ask you to find any slopes in the homework assignment. What's the slope formula, Genesis? Yeah, it looks somewhat similar to what Abby tried to give me earlier. But remember, y's over x's. Y's over x's. So midpoint is unique in that you add before you divide by 2. Slope is unique in that the y's go over the x's. Order very much matters, remember, in the slope. But they didn't ask about that in the homework. Questions on the first part of the homework? We're going to be able to do this Friday. All right. Page. The very next one, 189. And you did numbers 29 to 38, all of those. Finding the domain and range. Remember, domain class refers to all the numbers you can plug in. What letter will that typically be? X values, right? All the X values you can plug in. And then domain, or range rather, class refers to all the numbers you get out, or the Y values, or f of x values, right? So what you plug in, domain. What you get out, range. Okay? Range is what you get out. Domain is what you plug in. All right, so just making sure we've got it straight. If there are no limiting traits, Michael, domain and range will both simply be?
Numbers.
There are 5 limiting traits. Give me one of them, Kendall. Okay, even roots, radical functions are going to cause a problem for us. Fractions, they're annoying, aren't they? Constant functions are weird. Quadratic, that x squared. Well, that comes from the quadratic. The parabola is there. Anyone remember the last one? Absolute value would be the last one that affects domain and range. Number 29, what did you get for your domain, Kendall? All real numbers. What about your range? All real numbers as well. Number 30, right next to it. What did you get for your domain, Michael?
All real numbers.
All right, and what did you get for your range?
All real numbers.
Not on number 30.
8 to 8.
Yeah, just 8 to 8 is correct. Because it's a constant. You can plug in whatever you want, but you're only ever going to get an 8 out of it. Number 31, Maddie, what did you get for your domain? All real numbers. What about your range? Good. That absolute value is only going to produce negative numbers. And so, let's see, where's the other part of the homework? Oh. It's only going to produce negative numbers, which would normally be, that means negative infinity up to the 0. But, while you're turning, and then you graph. Good. Oh, you did them on 2 separate graph grids. You are no mathematician. Mathematician's too lazy for that. Anyway, sorry. Back to my train of thought. Number 31, again, because it's a negative absolute value, it's only going to produce negative numbers, which means all of these. But then they take the absolute value, which would only produce these numbers, and they add 9 to it. So that adds 9 to 0, which takes you up to the 9, and adds 9 to negative infinity, but since it's still conceptual, it's still negative infinity, and hence negative infinity to negative 9 with the bracket, of course the parenthesis there. What about number 32? What was your domain? Genesis? All real numbers, and your range?
I had positive infinity to 28.
I'm sorry?
Positive infinity to 28.
Well, okay, so we're right in that it goes to the positive infinity, right? 0 to positive infinity is what absolute value normally produces, right? And then you add 28 to it. Well, you add 28 to infinity, it's still infinity. You add 28 to 0, it's now 28. But we don't read it infinity to 28. We read it 28 to infinity, right? Always starting from left. That's a horrible infinity to right. That's really bad. As opposed to here, the left is the negative infinity to the right, which is the 9. Does that make sense? So negative infinity up to 9. Here it's 20 up to the infinity. Number 33. Quadratic function. What's the domain? Audrey?
All real numbers.
It is all real numbers. The range, though, and you have to remember, what shape do you get from the quadratic class? Parabola, right? So we get a parabola, and so the parabola, if it goes up, is going to go vertex upward. If it's a downward parabola, it's going to be vertex downward, or rather, negative infinity up to the vertex. Specifically, which part of the vertex, the x or the y? The y value, because you're talking about range. You're talking about what you get out, the f of x, the y value. All right, so we're going to describe our range on number 33 as?
10 to infinity.
Good, positive 10 up to infinity. Again, the domain, all real, range, 10 to infinity. Number 34, what was your domain? Brandon? All real numbers again. What was your range this time? This time it's an inverted parabola because you have a negative before the x squared. So you're going to start at negative infinity and only come up as high as 1 before going back down toward negative infinity again. Number 35, what's your domain? Abby?
All real numbers except 5.
Ooh, careful. On 35?
I think I did a mixed thing or something.
Look at it again. Number 35. You're right, it's not all real numbers because what's special about a radical, specifically an even root? You cannot take the even root of a...
0.
Well, you can take the even root of 0. It's 0, right? Square root of 0 is 0. But you can't take the even root of a negative value. So if you did plug in a 5, that's okay, right? You can have the square root of 0. But if you plugged in a 6, 7,
8, 9,
all the way up to...
negative infinity.
Okay, wait, you were going toward negative infinity there? 6, 7, 8, 9...
10.
Positive infinity, right? You see, if you go toward positive infinity, you can't do that. So 5 is your biggest number. You've got to get smaller from there. So how should we describe the domain on number 35?
5, negative infinity to 5.
Good, negative infinity up to 5. Again, negative 5 is here. Well, you plug in a, 5 is here. You plug in a 6, no good. 7, 8, 9, 10, all of those numbers are no good. But 4, you can plug in a 4. 3, 2, 1. So negative infinity up as far as 5. That's the domain. That's what you plug in. What about what you get out? Very similar to absolute value here.
Negative 10 to infinity.
Good. That radical has an understood positive in front of it, which means that radical only spits out positives, or 0 to infinity. But then you subtract 10 from all those numbers, negative 10. up to infinity is your range. Number 36, what's the domain here, Kendall?
Negative infinity to negative 6.
You're right that negative 6 is your special number, right? You plug in a negative 6, that puts the 0 there. So that's always what I do, is I kind of figure, what's the magic number that creates the 0? Now I think negative 6, would a negative 5 be okay?
Yes.
What about negative 4?
Yes.
Negative 3, 2, 1, 0?
No. Yes.
Yeah. Positive 1?
No. Yes.
Number 36? Yeah. 2, 3, 4. Basically, anything positive. So negative 5, you go negative 4, 3, 2, 1, all into the positives, you're okay. But if you try to put in, or negative 6 even, excuse me, but you put in a negative 7, are we okay?
No.
No, that's where we start running into problems. So we can't put anything going down this way. It's only negative 6 that way. So we would say,
Negative 6 to infinity.
does that make sense? All right, what about the range? What's that thing going to spit out?
Positive.
And then at 20.
So, 20 to positive infinity.
20 to positive infinity, good. Number 37. Radical or rational function. This is the weird one. The domain and range are going to be anything except there's one specific value, x can't be, for now. One specific value, f of x can't be. What's the limitation on the x, Maddie?
All real numbers except 1/2.
On number 37, all real numbers except 1/2. Why? What's up with the 1/2? Right, if you try to put that in, it would give you a 0 denominator. You're not allowed to have a 0 denominator, therefore you cannot plug in a positive 1/2. What about the range, what it spits out? All real numbers except 5. Where did you get the 5 from? You take the leading coefficients, the 10, technically just the 10, and the 2, the leading coefficients. 10 and 2, divide them. That 5 that you get is the one value you can never actually get out of the function, no matter what you plug in. Like, if I wanted a 6, for instance, I'd put a 1 in for both of them, right? And that would give me 10 minus 4 is 6, 2 minus 1 is 1, 6 over 1 is 6. I'd get a 6. I could get all kinds of other numbers just if I got creative with what I plugged in for x. But there's no way to rig getting a 5 out of that thing. Number 38. What's the limitation on the domain in Genesis?
All real numbers.
Except,
And all real numbers except 3.
All right, so remember, we're looking at the denominator, and we're saying that the denominator, the 6x minus 24, it cannot equal 0, just like we did back when we talked about fractions. What number here would create a 0? We do 24 over s up? Positive, and then divide away the 6 to get
4.
x can't be 4. So the domain here is all real numbers except 4. By the way, if you wanted to, the way the book describes it, they say negative infinity up to the 4, and 4 up to the infinity, but not actually the 4s. And it's easier, I think, to write that, though maybe you're like, actually, I don't like writing the word except, you know? Okay? So you've got a couple ways you could represent the domain there. I usually do this way, but maybe you think that's quicker. What about the range? What's the one value the range will never be? 2. The 12 over 6 gives 2, so the range is everything except a 2. All right, there were 10 of these. Did anyone go 10 for 10? You got them all. Right, Brandon is ready to go on these. How many went 9 for 10? There's only one you missed. Understand it now, you're good. All right, how many missed 2, 3, or 4 of them? Okay, so no one missed over half, but we missed a few of them then. All right, the ones we missed, do we understand them, or would you say, can you give me another one like number blank? Is there one that you say, can you give me another one like this one? Because I think I get it, but I'd like to just make sure in my brain, yes, I really do understand this now. Genesis, which one, or ones?
Absolute value.
Absolute value.
31.
So something like 31 with the absolute value. All right, and we understand 31, 32, both absolute value. A lot hinges on the sign in front of the absolute value. But if I said f of x is equal to the absolute value of 2x minus 7 plus 3. Remember, the domain is everything you can plug in. What can I plug in, or what limitations are there on what I can plug in for x, Genesis?
All real numbers.
I plug in anything I want. But the range, what I get out, remember, we said the absolute value only spits out positives. Now, on a number line, how would I describe positive numbers? The positive numbers are where? Starting at the, well, technically, 0.00001 right here, right? So for all practical purposes, 0 up to infinity. These are positives, right? That means this is going to be 0 to infinity, but then we have to do what at the end? Add 3 more. So we're going to take this whole thing and we're just going to add 3 to it to get what? 3 to infinity. Does that make sense now? All right, so if I said f of x is equal to the absolute value of x negative 12 minus 1, what's the domain? All real numbers. And what's the range? Good, because this is going to be positive, but then we're subtracting 1 from our positives, just shifting it back a little bit. Negative 1, still to infinity. If this had been a negative there, what does that do to the domain? Class? Nothing. It's still all real numbers. Domain is unaffected. But as far as the range is concerned, now what kind of values does this spit out?
Negative.
Only negatives. Okay, on the number line, how would I describe negatives?
0 to negative infinity.
But since we read from left to right, we won't say 0 to negative infinity. We'll say
Negative infinity to 0.
negative infinity to 0. But then we said we're subtracting 1 from that. So we've got all of these values. That's my range. But I then subtract 1.
Negative infinity to negative 1.
There we go. Does that make sense now? All right. Any other questions? Any other types of functions? We worked absolute value. Anything else? Genesis or anyone else to say, can you give us another one like this? Maybe see it on the board. 34. The quadratic. So the key with the quadratic, where you've got the f of x equals, now I'm going to make something up that's not going to work. So you're on YouTube, so please don't fact check me. People in here, you don't have time to fact check me. But if I made something random up like x squared, negative 7x, positive 13, if the vertex happened to actually be at negative 3, negative 1. It's not, okay? At least I'd be shocked if it were. Okay, later again, I'm going to teach you how to actually find the vertex. I'm not taking the time to do that right now. But if this happened to be the vertex to my random quadratic I made up, the quadratic is either going to go up or it's going to go down. Genesis, which way does this particular quadratic go? How do you know?
Positive.
Positive in front. Tells me it goes up. If it were a negative, of course, that would mean it goes down. But since it goes up, that means my range is going to be from this point all the way up to infinity, right? So the question is, what is this point? Well, I've told you it's negative 3, negative 1. But since we're looking at the y, the f of x, the range, which number matters?
-3.
Okay, it's the y. We're looking at vertical. So negative 1. We're going to say negative 1 is this y value all the way up to infinity. Make sense? If there had been a negative in front, then now this right here and downward is my range. So now it'd be you would think negative 1 down to negative infinity, but we don't write it this way. We write the negative infinity up to negative 1. Make sense? All right, so if I gave you a quadratic of negative x squared plus 2x minus 5, and I said the vertex happened to be, again, there is really truly a vertex, if it happened to be at a negative 2, 4, what would the domain be, first of all? All real numbers. You can plug anything you want into a quadratic, but what about the range?
4 to, oh wait, no, negative infinity to 4.
There we go, the negative infinity coming up as high as 4, but that's the highest that the parabola will come before it reverses course and goes down. Does that make sense? All right. Any others that we have questions on or want to work a little bit more with? Any questions? You feel better? The rest of you feel good? All right. Turn over to page 607. Page 607. Got a little bit of a teal edge to the page. These are some edgy pages. Anyway. All right. Direct and inverse variation. Gave us a little bit of trouble on the quiz. I wanted to spend some more time working on it. And they've got some what are called extra exercises. I don't normally use them, but I think we need to for this concept because we're having a little bit of trouble here. I want to help you overcome that. All right, first of all, number one, all I want you to do is write the formula. Number one, at the bottom, this is the chapter 4 part, excuse me. Chapter 4 part of the bottom of page 607. I want you to write the formula for number one. It says, let m and n be directly related. So what's the formula, Maddie? M equals kn. All right? Then we plug in numbers for m and n so that we can find k. So how do I change it now? Kendall?
96 equals K12.
96 equals K12. And that tells me what K equals. Michael? 8. All right, so what's my actual formula? We said M equals Kn, but now I know more than I did before, so now I can be more specific, Genesis, and say M equals 8n. Make sense? So it says find m if n is 7. What do we end up with for m here? Audrey? 56. Because you plug in the 7 for the n, and n is 56. And there's our answer. Does that make sense? Start with the formula. Take the information they gave you long enough to find the k. And once you know the k, you're able to solve the formula. All right, number 2, at your seats. Number 2 at your seats. How did you set up your formula, Audrey?
F equals kg.
F equals kg. You plugged in the 6, you plugged in the 36, and you found your k to equal
6.
Ooh, careful. If you divide away a 36, 1 6. Now, if you'd said that g equals kf, you would get a k of 6. So there's two ways to approach it. If you said g equals kf, your k is 6. If you said f equals kg, then k is 1/6. Make sense? There's two ways to approach a direct variation, depending on which one you call dependent, which one you call independent. So then it says find f if g is 252. Well, if you approach it this way, you're going to get 252 equals 6f. If you approach it this way, you'll say f is equal to 1/6 of 252. Well, either you're multiplying by a 6th, or you're going to divide a 6 from both sides to get your f. Either way, f has to equal what? Anyone? 42. Does that make sense? Okay, two ways to do it. Neither one is wrong. Okay, I don't like fractions, so I kind of prefer this way. But same answer either way, right? It's just up to you. Questions on number 2. Number 3, read it for us, Abby.
The school's profit from a candy fundraiser is directly related to the number of students in the school. If the school profited $7,000 from the candy fundraiser when 350 students were enrolled, how much would they profit if 460 students were enrolled?
At your seats, write a formula. I think we've got profits and students is kind of the two things I'm looking at. We got profits and we have students. And they are directly related in more ways than one. I always say we're not in it for the profit, but if there's no profit, we're not in it. So, or at least we can't stay in it. If there's no profit, we can't stay in it. So there has to be profit, then we're not in it for the profit. How many said profit is K equals K times students? All right, so 7,000 profit equals K times 350 students. How many found the K to be $20? Constant of 20. So then, if we have 460 students, we've got a constant of 20. How much profit should we expect, class? $9,200. How many found that to be the profit? Questions? All right, number 4. The boss of a construction company knows the number of gallons of water needed for workers to drink is directly related to the number of workers. 12 gallons of water were consumed when 20 workers were scheduled. So if they're going to schedule 35 workers, how many gallons of water do they need to have ready? I would go with gallons and workers, because if you do water and workers, you're going to run into trouble with which one's which W, right? So I go gallons and workers. Either way works, just whichever one you happen to pick. How many had one of these process all the way through? You either had this or that, your K was correct depending on what you started with, you ended with 21 gallons needed. Do we feel like we got direct variation now? All right, turn the page. Let's look at inverse variation. Remember, with inverse variation, the way we're going to do it, there's only one way, which actually makes it a lot quicker and easier. You always multiply the variables to equal one consistent product. So, if it says P and Q are inversely related, then what's my formula going to be, Genesis? P and Q are inversely related. Just PQ equals K. You multiply it equals something consistent. Now again, the book would say P equals K over Q. We don't do that here. We're just going to say PQ equals K. And since the numbers they give us are 22 and 14, we can easily find K. Well, with the calculator's help. $208, how many got the same thing? 308? I'm deaf. 308, we like that number better?
Yes.
All right. So really, what's my formula, class? PQ equals 308. We just didn't know it till we had to find it, right? PQ equals 308. So, if Q is 4, what's P? 77. Make sense? Do 6. I don't know why the 1 to you. All right, how do we do? Do we find the K to be a fourth? TV equals a fourth, so 2 times 12 equals a fourth, T is 1/48. All right, go on to number 7. A gym owner found there's an inverse relationship between how many people enroll each month and the price of a month's membership. 180 people enrolled when the price was 20. How many people are going to enroll if the price is 30? I'd go with price and enrollments. What says P and P for people and enrollments? People and price, that doesn't work. So with people and enrollments. sorry, 180 enrollments, $20 price. So $30 price. We good to go? Feel like we're understanding it better? All right, do the last one. Mechanics and price of oil change. I go with mechanics and price. You worked ahead? Show off. Must be nice to know how to find the midpoint too, huh?
Real nice.
I don't hate you, Abby. I really don't. I just like picking on you.
I do too.
In my defense, I was gone for that lesson.
Oh, yeah. Kind of an economics principle, supply and demand. There's only 4 mechanics in town, you're paying $35 for an oil change. So mechanics times price equals is constant, it's 140. 7 mechanics in town, there's more competition. They don't need to charge as much because there's fewer people coming in. They got to try to drum up business. The prices go down to $20. How many got $20? Actually, dollar sign. $20 for the price of an oil change. All right, we struggled on the quiz a little bit. Feel like we got it now. All right, homework for this evening is to do pages 219 to 220. Pages 219 to 220. Do 2 to 28 the even. Pages 219 to 220. Do 2 to 28 the even. Again, test coming up Friday. That's lesson 105 over sections 4.1 to 4.5. We are reviewing again tomorrow. Test Friday. And then we will move on to our next thing. Have a wonderful rest of your day, and you are dismissed.